Hello, welcome back to the vibration class. In today's episode, we are going to talk about the degree of freedom. So, in vibration, when we talk about degree of freedom, we are referring to the number of ways. So, the number of ways, or let me make it very simple. So, when we talk about degree of freedom, it is the number of independent, let's bring that word, independent ways a system can be excited. So, degree of freedom in simple terms is the number of independent ways a system can be excited. When we talk about a system being excited, let's talk about a way that a system can be disturbed. So, if the system is not excited or disturbed, it is naturally lying down. Let's move by getting a spring. If this spring is not excited or not disturbed, it is naturally occurring this way. At the moment I apply a force F to this string or this spring, right, it is going to behave abnormally. So now its length is going to change this way, and I'm going to experience the force that way. So what do we see? We can see that there has been a change in what? The length over here, and there has been also a change over here. So we can see that there's a little deviation inside the system. So the number of ways a system can be excited is what we refer to as what? Degree of freedom. In other ways, we can also define degree of freedom as the number of masses. So it is also very simple. I'll explain that the number of masses multiplying the number of ways the mass can move, number of ways the mass can move. All right, so the same experiment A and B. So how many masses do we have? How many springs do we have? We have one over here. How many ways can we excite this spring A? We can excite it in either way, forward or what? Backwards, right? So when we know the number of ways that we can excite or disturb the system, we also learn about how to disturb or excite systems in vibrating bodies or in bodies that have mass and elasticity. All right, so but simply to understand the degree of freedom, I always prefer the number of ways a system can be excited, and we will also understand that. Now we have one way, which is if the system can be disturbed only one way, then we call that as degree, 1 degree of what? Freedom, or what we call single degree of what? Single degree of freedom, meaning that system can be disturbed only in one way. You can never disturb it or excite it. Let me use the word excite it in two ways. What I mean is, let's look at this. If I have a spring attached here this way, with a spring constant K attached to a mass M, if you want to disturb this, it is only one way, right? You either pull, it's only one way, so you can disturb it by pulling it down, right? So when you pull it down, then you can see the swinging motion of what? The spring up and down. So this means this body can be disturbed or excited in a single way, which is a single degree of freedom. You see that? If it is not a spring that way and it is a rope, so if I disturb it this way, it's a single way, right? Or if I disturb it upwards, remember this is a spring, so I can push this mass upward and release. When I release, it will start vibrating. The spring will start moving. Do you see that? Okay. It is either up or down. You cannot excite it using both approaches, like where the same one mass, you pull it up and you pull it down at the same time. It is either up or down. You get it? All right. So if it is also, let's say, a hook with a something, let's say this is a rope, an elastic rope with a mass here. I can disturb this in only one way. I can either pull it to the extreme right and disturb it. So when I pull it up to this point, I'll leave it. It will start swinging up and down. Or I can pull it back to this place once and release it. It will also start swinging this way and backwards, right? So in both cases, you can see that the disturbance or the excitation happens in only one way, up here or here. For the spring, it is either you do it up or you pull it down. This is what we mean by a single degree of freedom. Now let's look at 2 degrees of freedom. And the number of degree of freedom is also going to be dependent of what? The mass. We can see that we have one mass where we are having a single degree, and we're also going to have 2 for double or 2 degrees of freedom. So let's look at 2 degrees of freedom. This means we can excite the system in 2 ways. So this is a spring and it attached to first mass, and this is another spring attached to a second mass. So this is M1 and this is M2. So what can we do here? If we want to excite this system, it's either I focus on this mass to disturb it down, or I focus on this mass to disturb it up. That is one way, right? Or I focus on this mass to disturb it down, or focus on this mass to disturb it up. Because the moment I pull M1, the whole system is going to start vibrating. That is a one way of disturbing. That same system B can be excited by focusing on mass 2. In any of the mass I touch, this system is going to start vibrating. So I have 2 ways of exciting it, either by mass 1 or by mass 2. This is what we call 2 degrees of freedom. You see that for the 1 degree, you can only do that by mass 1. There's no mass 2. So for the 2, you can also do that with mass 1 or mass 2. The same thing happens if we have, let's say, a rotating object this way, where this one is attached to, let's say, a disc where I can rotate it. You do the analysis on all this and you understand the way we excite things. So here I can excite this system by either rotating let me call this mass 1, right? Mass 2. By rotating mass 1 clockwise or rotating mass 1 what? Anti-clockwise. Any of them, when I do that and release, the system will start vibrating. It's a one way. Whether if I come to mass 2 I can disturb it clockwise and what? Anti-clockwise. The system will start vibrating. So for a single system days, I can excite it using mass 1 and using mass 2. This becomes 2 degrees of freedom. So with this idea, you can now understand 3 degrees of freedom, 4 degrees, when there are 4 masses where you can disturb it with 4 of the masses. Very simple. Karaoke. One we have to also know is that we have a way to disturb where we have infinite degree of what? Freedom. That means the system can be disturbed by so many ways of what? So many ways. When we have a beam cantilever beam. You know, when we talk about cantilever beam, that means a beam that is fixed at one end and it is what freed at the other end. With this beam, I can excite it by a number of ways because I can put my finger here, release it to start disturbing, moving up and down, right? I can push it from this side, it will start vibrating up and down. Here it will start vibrating. If I do it here, it will. If I do it here, it will. So you can see there are a number of ways. You cannot count, right? I can push it backwards, a whole lot of ways to excite the system. This is what we mean by what? Infinite degree of what? Freedom. So with this small explanation, I hope you understand the degree of freedom so that in our analysis, when I say we are going to have 2 degrees of freedom, you understand. The proper mathematics is coming and we will do the analysis. In the next episode, we are going to talk about simple harmonic motions and we are going to derive the equation. Thank you for watching this episode. Kindly subscribe to the channel and see you in the next episode. Thank you.